morning, everyone. I'm Binita Casey. I'm a postdoc in Northeastern University, Boston, USA. And this paper, the co-authors of the papers are Dr. Marcel Shepard, who is a professor in the University of Georgia, USA, and also Cassandra Johnson-Gaither. She is a social scientist in USDA Forest Service, Georgia, USA. So this is the outline of my study. First, I will talk about how climate change is affecting Southeast United States. Then I'll discuss about impacts of climate change and how vulnerable is Georgia to climate change. I'll discuss about the methodology, show you some results and conclusions. So IPCC 2007 defines climate change as a statistically significant variation in either mean state of climate or in its variability persisting for an extended period of time, typically a decade or longer. This graph is taken from the SREX report of 2012, which discuss about the extreme events in climate change, and we can see that climate change affects the frequency, intensity, or spatial extent, timing of the extreme events, and these extreme change in the extreme events can be seen through the change in the shift in the mean, or change in the variability, or change in the symmetry of the probability distribution curve. So the first graph here shows that when the mean is shifted towards warmer climate, then we have more number of extreme hot events, whereas the number of cold events decreases. But when there is increase in the variability of the probability distribution curve, then there is some, there are more number of extreme hot events as well as number of extreme cold event increases. But when there is change in the symmetry, then the mean remains same, whereas there are extreme hot events increases, whereas the cold events remain constant. So this is the study area. My study area is Georgia, state of Georgia, which is located in the southeastern United States. And Georgia is divided into 159 counties, subdivisions, and those red dots are the city locations in Georgia. Atlanta, which is the popular city, is also the biggest city in Georgia. So in United States, United States National Climate Assessment Report shows that temperature has been rising in United States by 1.1 degrees centigrade since 1970s, and there are also decline in the number of frost days per year. There are heavy precipitation events, especially in the northeastern United States. And in addition to that, there are also increase in the number of drought events since the mid-1970s. And also a number of frequent and intense hurricanes and flood events are also seen in United States. And there have been also, in addition, there have been increased number of heat wave events. And there is a phenomenon called urban heat island effect, which is further making the heat wave events worse. And this report shows that by the end of the century, there will be a rise of temperature by 1.5 degrees centigrade to 2.5 degrees centigrade under low emission scenario, whereas the temperature will be rising by 2.5 to 5.5 degrees centigrade under high emission scenario. And there are also increases in the number of flood events, and the historic water level of 3.5, which is equal to about 1 meter, 8 feet are above the local high tide line. These are forecasted by the end of the century in the coast of Georgia. So among many impacts of climate change, some of the impacts are felt are the heat-related stresses in human health, and also damages in the crops are seen, and also the infrastructure damage due to the flood events and extreme events, and also we can see the diseases outbreak. and also we can see the decreased availability of water. So these are the impacts that are felt in the United States due to climate change. So vulnerability to climate change is defined as the degree to which a system is susceptible to, unable to cope with the adverse effects of climate change, including climate variability and extremes. This is the definition of IPCC again. And IPCC defines vulnerability as the function of exposure, sensitivity, and adaptive capacity. Exposure is the degree to which a system is exposed to climate variabilities, whereas sensitivity is the degree to which a system is susceptible to the variabilities. And adaptive capacity is the extent to which a degree to which our society or system can adapt to the climate change. So I have used, so this definition of vulnerability is used in this study. So there are different components of vulnerability. First one is social vulnerability, which is the internal characteristics of a system. So this social vulnerability exists whether there is extreme events or there is climate change or not. So this is internal, and there is social vulnerability within the system. And another component is biophysical vulnerability, which depends upon the frequency and severity of hazard or extreme events, such as flood or heat wave or through hurricanes. And in addition to this social vulnerability and biophysical vulnerability, there is third component, which is called the hazard, which is explained by the hazard of place model. So based on this model, so our society is vulnerable to itself because of its location, because where people choose to live or where people are forced to live. So for example, the coast of Georgia, the coastal counties in Georgia, or most of the coastal cities in the United States are populated by the rich people, but still they are vulnerable because these are the locations where they get more hurricanes and they get storm surges and all those events. These are the three components of vulnerability which are considered here in this study. So the data sets I have used for climate change projection in 2030s, which I have defined as like 2025 to 2034. So these 10-year climate projection data sets are acquired from the CIMI-5 data set, which is the recent climate projection, and I have used RCP scenarios, which are the emission scenarios 4.5 and 8.5. 4.5 is the baseline scenario, and RCP 8.5 is the high emission scenario. So for this, I have used the ensemble averages of global climate models. So the models in the table are the ones that I have used for the projection. And mostly I have used the mean monthly temperature and precipitation data sets to project the future climate, and these all those models are used in using the mean monthly temperature and precipitation. Whereas in case of daily temperature, so the daily temperature, which is the maximum daily temperature, and daily precipitation data sets are also used to project the frequency of extreme events in the 10-year timeline. And mostly the data sets were available only for NCAR model, NCAR from the NCAR, and then from the GFDL. So these two models were used to project the frequency of extreme events in future. In addition to that, to the climate data sets, sea level rise data sets are also used. So the coastal inundation map, like the coastal flooding map, was used as a basis for the sea level rise in future and coastal storm surges. And in addition to that, socioeconomic data sets are acquired from the various sources are used to predict what is the social vulnerability in future. So this methodology is basically based on a recently published paper in Applied Geography, which discusses about the what is the climate change assessment in Georgia from past to present, and this study builds on that paper. And here I have used anomalies in temperature, in mean temperature and precipitation, to show like how the mean temperature and precipitation will be changing in the future in 2030s. And for that, G-score is used. So the G-score shows the anomalies in mean decadal temperature and precipitation in 2030s compared to the baseline climate data from 1970s to 1971 to 2000. So this 30 years of normal climate data set was used as the baseline, and it was compared with the 2030s data to show what are the anomalies in mean temperature and precipitation. The extreme events were measured in terms of heat wave events and extreme precipitation days. So the heat wave was defined as the events where the daily maximum temperature exceeds the 97.5 percentile, and they occur like 3 days in a row. So that was defined as the heat wave events. Whereas the extreme precipitation days were defined as the number of days where the rainfall is greater than 1 inch or 25 millimeter of rainfall. And from that, from the heat wave events and a number of extreme precipitation days, those were merged together to define the mean decadal frequency in 2030s. Similarly, the socioeconomic data sets were used to project the social vulnerability in 2030, and for that, cohort component model projection is used. So this cohort component projection is the widely used projection model to project the demographics. This was used using the migration data sets, the fertility data sets, survival rates. This projection was used to derive the social vulnerability in 2030. And in addition to the socioeconomic data sets, some of the data sets such as employment data sets, like population involved in how many of the population will be involved in agriculture or natural resource based industries. So for that, constant share method was used, in which so my study is by county level. So what will be the employment in the county level compared to the state level. So the data sets for social vulnerability projections I have used is the African American population in United States in each of the counties, and what are the Hispanic population. So these two are the racial minorities in U.S. And these are used as the indicator of like social vulnerability. Similarly, elderly population and infant population was used because most of so for example in heat wave events or some extreme events, this elderly population and infant population are the ones that are mostly affected. Similarly, the people who are employed in the natural resource-based industries are also vulnerable, and these are also taken into account. Similarly, the people involved in construction industries, because these are the people who work outside and are exposed to extreme events such as heat wave. And personal income per capita is used as the adaptive capacity variable. So from these variables, social vulnerability is derived, and also the decadal anomalies in temperature and precipitation are also used. As I mentioned earlier, so I have also used the frequency of extreme events such as extreme precipitation and heat wave events. Similarly, in addition to that, sea level rise data sets such as what will be the percentage of land inundated by several feet of water levels. So for this, data sets were acquired from Surging Seas website, and this is based on the these inundation data are based on the bathtub approach, in which models the also based on the hydrological connectivity and locally adjusted mean high water levels or local higher water level. So these are the results. So this is the social vulnerability map in Georgia by county. There are, as I already mentioned, there are 159 counties in Georgia, and so most of the so the high social vulnerability is seen in the southern part of Georgia mostly, and also in the southwestern part of Georgia. And this is the temperature and precipitation anomalies in terms of this. This is the change in the mean temperature and precipitation in 2030s compared to 1971 to 2000 average. So the higher anomalies are seen in the southwestern part of the state. This is the higher precipitation, extreme precipitation events. So mostly the northern part of Georgia gets the most rainfall, and most of the extreme precipitation events are also recorded in that region. And this is the heat wave events projection. So the frequency of heat wave events were really higher near the Atlanta area, Atlanta city. So mostly those are the locations where they will be getting most of the heat wave events in 2030s. So this is the overall climate vulnerability map, and here all the variables like the socio-economic, social vulnerability, as well as climatic vulnerability, and like due to projections, vulnerability due to sea level rise and storm surges are taken into account. And we can see that mostly the Atlanta metro area and the southwestern part of Georgia is most vulnerable. In addition to that, the coastal area. So these are the coastal counties in Georgia, and these are also vulnerable because of the storm surges and sea level rise in future. So. In addition to mapping what is the vulnerability in climate change vulnerability in future, we also looked into some of the counties, which was 3 counties, to compare like what is driving the climate vulnerability. So what factor is the most important in each of the counties. So the Gwinnett County, which is this county, is the urban county, and here we can see mostly the heat wave, extreme event is driving the vulnerability in the urban areas. Whereas this is Stewart County, is a rural county located in the southwestern part of Georgia. And here we can see social vulnerability as the most driving factor towards climate change vulnerability. And this Chatham County, this county is the coastal county. Here we can see that the coastal coastal flooding is the most driving factor of overall climate change vulnerability in future. So in conclusion, most of the urban area, which is mostly the Atlanta metro area in Georgia, will be getting the highest frequency of extreme heat wave events, and mostly the heavy precipitation events will be seen in the northern part of the state. And also like higher anomalies in mean temperature and precipitation will be seen in the western part of the country, where most of the people are based on like agriculture and forest. forestry is their for their livelihood. And so we can see that in general, like the Atlanta area, like the city area, and the Southwest, which is the rural area, both are climatologically and socially vulnerable, but the coastal counties are most vulnerable due to their location. Thank you. If you have any questions, please go ahead.
There are some questions. Please, from your name, your institution. Thank you.
I'm Marla Potus. I teach at Hardin-Simmons University in the United States and Texas. And a very nice study. I like how you are combining social information with environmental information, because sometimes that's what's missing in a discussion of the impacts of climate change. And so I just wanted to make a comment. What kind of stands out to me for planning, for risk assessment, scientists are on looking at problems from different perspectives. But something interesting to me that I just want to point out is that from a policy perspective, this study shows that the impacts of climate change can vary greatly depending on the region locally, which would indicate, local government or regional government, they would need planning to address their specific concerns. So it shows the difficulty in having national policies that don't consider the localized effects of climate change. And I think your study shows that very nicely for a policy perspective.
Thanks. Any other questions?
Other question, other observations? I have one question.
Yeah, sure. Go ahead.
Always to fit the very important different scientific community. One is climate change people that are not mostly, could be geologists, but not specifically, and earth science. So in your paper, what is the link? The skill you used as geologist to plan, to understand your percentage of you show in this paper. So what is the geological job done in this paper?
Okay, first of all, I'm from geography, so not geology. So I think you're asking from the geographical perspective, right? Not the geology. So yes, this is you said for the planning, how is from geographical perspective. As I already mentioned, there are different, not all even within a state, there are different socioeconomic conditions and climatological condition, local climate. So I think that should be considered, and that should be considered for planning before, what is the socioeconomic condition of that place, and how is the adaptive capacity of that place. I think that should be taken into consider before planning. I don't know if I answered the question. Did I? Okay. Okay, thank you.